All right, guys, so here's the thing. I hope you have your sets out for 2.3. We're going to finish those, and you guys should be set up to do a few things. We might do a little bit of like how we played the bean game yesterday, but we'll just do it visually with all of us here. So we did intersections yesterday. We did unions yesterday. We did subtraction, right? So B minus A or A minus B. We sat and we looked at what that was, and then we also did the complement. So the complement is everything that's in the universal set, but it's not in the set that we're working with. So the order of set operations is just like order of operations with anything else. Think through parentheses. First, we're going to work left to right. So we have this example 5. So we have the universal set being the numbers 1 through 10. Then the next thing that I know, it's 1 through 10. E is even numbers 1 through 10 of my universal set. B is the set of numbers 1, 3, 4, 5, and 8. And A is the set of numbers 1, 2, 4, 7, and 8. So here's the first one, A union B. So here's the thing. I'm going to label this Venn diagram A. I'm going to label this one B. I'm not even going to worry about the fact this says complement. I just want to fill this out to figure out what I need. So A is 1, 2, 4, 7, 8, and B is 1. So I know 1's going to go right here. 3, 4 is going to go in the center as well. So I've got 1, 1, and 4, 1 and 4, and then they both have what? 8. So I know 1, 4, and 8 go in the center. So I've got 1, 4, and 8 gone. I've got 1, 4, and 8 gone. So in B, I also have over here 3 and 5. In A, I have 2 and 7. But here's the thing. I want the complement. So I need to get what should be on the outside of A and B. So I have 1, 2, 3, 4, 5, 6 is on the outside, 7, 8, and I'd have 9 and 10. Right? So here's the thing. A union B is everything on the inside, but I want the complement, so I want everything that is on the outside. So everything on the outside is right here. I'm trying to highlight it really well. Right? So what I have is 6, 9, and 10 in that set. Okay? So right here, I'm just going to rewrite that 6, 9, and 10. So then I have that intersection, E complement union A. So I'm going to come over here and I'm going to label this Venn diagram that I have right here, E, and I'm going to label this A. So here's the thing. E is an even number. So right here in A, I have how many even numbers? 2, 4, and 8. So here's the thing. I know 2, 4, and 8 are all even numbers, so those are going to go in the center. So A is 1 and 7 are going to go over here. And then E is even numbers. So I got 2, 4, 6, 8, and 10. So that's what's going to go there. So here's the thing. Then I have to get everything on the outside because it's E complement. So let's think through what should go on the outside. So I've got 1, 2, 3 would go on the outside. 1, 2, 3, 4, 5 would go on the outside. 6, 7, 8, 9 would go on the outside, and then I have 10. Okay, so that's everything that is on the outside. So I need E complement union A. So E complement is everything on the outside of E. So I'm going to go back over here to my highlighter. Highlighter. So E complements everything on the outside. Okay. Union. So that means all of what I have of A, right? So I'm going to highlight all of this. This is my E complement. And I'm unioning everything I have of A, which is all of this, which is I'm highlighting here. So then my set that I'm dealing with is going to be everything that's highlighted. So I'm just going to write it in order. 1, 2, 3, 4, 5. So I've got 1, 2, 3, 4, 5, and I don't have 6, and I have 7 and 8. 7 and 8, and then I also have 9. Okay, so I dealt with one, I dealt with the other one, so now once the intersection, so just looking at where I have stuff that is the same, I have 6, 9, and 10, and over here I don't have 6 or 10. The only one that is going to intersect that they have the same is 9. So that answer then is 9. Okay, easiest way to see it is with your go! Alright guys, we're going to go over and we're going to do our next example. So on this one, same situation, right? I have the universal set, A union B complement, and then I find A complement union B complement. So universal set is 1, 2, 3, 4, 5, and then B is 1, 2, 3, and A is 1, 2, 3. So on this one over here, I'm just going to scroll down, give myself some space. So here's the thing. What do A and B have in common? 1 and 3. So I'm going to go 1, comma 3, because they both have 1 and 3 in the center. Right? And here's the thing. I'm going to label this A, and I'm going to label this B. A is going to have 5 in it. B is going to have 2 in it. And then I have the numbers 1, 2, 3, 4, and 5 as my set. So I got 1, 2, 3, 4 is on the outside. So these have to be set up the same. So I'm just going to come over here to this one and write that same information down over here. Okay, so I have A union B, so I'm going to highlight all of this. A union B. So A union B is all of A and all of what? B. But I want the complement, and the complement is then the only thing I have left. So my answer is going to be 4, because it has to be everything on the outside of it. So the only thing that works is 4. So now we're coming over here. I need A complement, so I'm going to highlight that. Tools, highlight. A complement. I'm going to label this A, and this was what? B. So we're coming over, we're doing this. So A complement is everything on the outside of A. Okay. B complement is everything on the outside of B. So the union means it's everything I have highlighted. So I have 4, 5, and 2 highlighted. So then my answer is going to be, I'm going to write it in order 2, 4, and 5. And that then is my answer for that problem. I think it's really easy to see these when you have them set up as a Venn diagram. Okay. So the next one, I just want to talk about De Morgan's law. And this is what's going on. If A and B are sets, then A union B complement is equal to A complement intersection B complement. And this is saying A intersection B, the complement of that is the union of A complement B complement. So I just want to talk through this. I know I did not have a diagram, but I want you guys to see what this is meaning. So A union B is everything on the inside. So I'm going to highlight. So A union B is everything on the inside, right? And then the complement, so green, right, that's going to be all the region on the outside, right? So if I labeled that region 1, 2, 3, and 4, so region 4, 1, region 2, region 3, and region 4, this is going to refer to region what? 1. So A intersection B, if I do another one of those, so A complement, so I'm going to do this. A complement is everything on the outside of A, and that's really hard to see. Alright guys, so we're back to where stuff is at, and what I wanted to do is set us up so you could see what this means. So I'm going to make this one A intersection B, and that's one's going to be the complement. This one's going to be A union B complement. And this one's right here is going to be A union B, outside parenthesis complement, and then A composite intersection B complement. So tools, highlighter. Here we are. So this is A union B. is everything on the inside. So the complement has to be everything on the outside, which we've already discussed, right? So this is A, this is B. We got region 1, region 2, region 3, and region what? 4. So I know that this one is equal to region 1. So A complement, talk about that. A complement is everything on the outside. So I'm going to do that. B complement is everything on the outside. But the intersection means it has to be the overlap. So if I have region 1, region 2, region 3, region 4, the only overlap that I have is in region what? 1. So that's how come those are both going to mean the same thing. Over here, I'm going to label A, B, region 1, region 2, region 3, region 4, region 1, region 2, region 3, region 4. Tools highlighter. Okay, intersection of A and B. The intersection is here. Okay, A and B intersection, but I need the complement, so that's everything outside of that. So that's going to be everything I'm highlighting in green. So that's going to be equal to region 1, region 2, region 3, and region 4. So that's region 1 plus region 2 plus region 4. So then I'm coming over here. A complement is everything on the outside. B complement is everything on the outside of B, because I can't include any of B. And so here's the thing, it's union, so what regions do they touch? Region 1, region 2, region 4. So then this is region 1 plus region 2 plus region 4, right? I think it's easiest to see this. So this is just ways to see how you can get just the center value, like everything but the center, and then if you wanted just the outside, how you could get just the outside of your sets. All right, so here's the thing. We got example 7, and then we talk about inclusion, exclusion, and we're done.